Alright, in this group of notes, we have 3-5 notes, graphing quadratic functions. Your objective, you'll be able to graph a quadratic function and compare and analyze different coordinates on that function. Alright, so here's one of the problems that we're going to be doing, what it looks like here. So the figure shows a graph of the function of f of x in the xy coordinate plane with the vertex at -2, 14 and the zeros of that function where it crosses the x-axis. So f of x, here's our equation, y is greater than or equal to -2x squared minus 8x plus 6. So let's first graph this equation. Because if it's not graphed, it's probably a good idea to graph it. So -2, 14, so 10, 11, 12, 13, 14. So right there is our vertex, that blue dot. Now, that blue dot's at -2, so let's plug in -1 to see where the output is, where we got to put in our dot. So when we put -1 in, -1 squared is 1. 1 times -2 is -2. -2, well, -1 times -8 is 8, so -2 plus 8 gets you 6. And 6 plus 6 gets us 12. I did something wrong there. Alright, so I'm going to put -1 into my graphic calculator. So I do -2, parentheses. We're checking -1, so you put in -1, close parentheses, squared, minus 8 times -1, close parentheses, plus 6. I get an answer of 12. Oh, pardon me. So -1, 12. -2, 14. I went down to -14. Silly me. So that original blue vertex is actually up there. I'm also going to now try putting 0. So I put in 0 in there. So I do -2, parentheses 0, squared minus 8 times 0 plus 6. And you get positive 6. So when you plug in 0, you get 6. Then you know it's a reflection because you've been graphing these for a while now. So there's our graph function. That's our top one here in blue. We also need to graph the function -8x plus 18. So -x plus 18, so we go to positive 18, so 15, 16, 17, 18. So in red, I'm doing this line here in red. And we go down 8 to the right one, because that's what slope of -8x means. So you go down 8, 1, 2, 3, 4, 5, 6, 7, 8. And you go to the right one. I'm going to draw my best line I can. It's always good that you just graph everything on the graph paper, a separate piece of graph paper. Make it all work out. So this is my red line. Alright, obviously it's not perfect. I'm not expecting perfection out of you guys either. Now, once we have those two graphed, we have to now compare the coordinates. That's what option A, B, C, and D are. We're going to check all that applies, so which statements are true. So I'll do that in purple. So f of 2 is greater than g of -4. So when I say f of 2, f refers to the f of x function, which is this guy on top here. So when this function is at 2, so 1, 2, that function is probably going to be down somewhere around here if we follow that arrow. So f of 2 is greater than g of -4. So when g is at -4, so that when that red line is at -1, 2, 3, 4, we assume it's going to be somewhere up here because that's where the line is going. We're saying that this dot here is greater than that dot. Clearly that is not true. This original line, the f of 2, is less than the g of -4. So that's not true. We're not going to put an x in there. We're not checking that checkbox. For B, f of -5. When this blue function is at -5, 1, 2, 3, 4, 5, approximately probably somewhere around here, when it's at negative 5. This dot is greater than when g is at 0. When g is at 0, that's up here. Is g at negative 5? Is that greater than this one? No. This one is clearly higher than this. So B is also false. So we don't put a check and a checkbox in there. F of 1. So when the blue function is at 1, so somewhere around here, that purple point compared to g of negative 6, g of negative 6 is somewhere up here. Is this dot greater than or less than? Well, you can see it's lower, so it's less than. So f of 1 is less than g of negative 6. So we put a little check or a little X in that little box. We're going to check off C. I'm comparing those coordinates. Last but not least, we're going to look at D. Is f at negative 5, so the function at negative 5, or just somewhere around here, is this less than g of 10? Well, g of 10 is all the way to the right, and it's way down here. Is this dot less than this one? No, the dot on the right is less than, or the dot on the right is less than that dot. So that means D is not true. So our only one that was true is option C. So we'll just click the box for C as far as select all that apply. Alright, let's do another one. These are tough. So we first got to graph the functions, both of these functions on the graph. So the one vertex is at negative 1, 5. So we go 1 to the left, 5 up. Let me plot that point. Now we got to graph this function, 1x squared plus 2x plus 6. Well, if I put 0 in, I want to find out where that output is. So 1 times 0 squared plus 2 times 0. We're going to see that it's a result of 6 in the calculator. So that means negative 2 is also at 6. And then if I put 1 in there, 1 squared is 1 times 1 plus 2 times 1 gets you, that's a total of 3. 3 plus 6 gets you 9. So when x is 1, our y output is at 9. Let me do a little reflection. So this is our little parabola. And you gotta remember it's going up. It's going up fairly quickly. With a graphing calculator, you could obviously graph that a lot quicker, a lot faster, and you could plot those coordinates a little bit faster and accurately using the table. The g of x function, which I'm going to do in red, is 5x minus 15. So we plot a dot at negative 15 because that's our y-intercept. Negative 11, 12, 13, 14, 15. And our slope is 5 over 1. Rise of 5, run of 1. I'll connect those dots. I'll make my red line so you could easily see the red line graphed. So 5x minus 11 is that red line graphed. Now we got to compare some scenarios, which I'll do in purple. So looking at scenario A, we want to see if is statement A true or is it false. So f of negative 4. Well, the f function refers to the blue one. So when f is negative 4, so 1, 2, 3, negative 4, it looks like the arrow's kind of pointing around here. So is that point, that purple point, is it going to be less than g of 10? Well, g refers to the red line. And when the red line is at 10, which is way off the graph, you see it's like all the way up here. So is f of negative 4 less than g10? To me, it does look like that's the case. So we put a little check or highlight or darken that box for A. So it looks like A is correct. That's a true statement. Now we're going to try f of negative 3. f of negative 3 looks like it's around there. I'll erase the old purple points. So that purple point, f of negative 3, is that less than g of 5? So I'll go to the g, the red one, 1, 2, 3, 4, 5. Which one's a tough call? Is this purple one less than on a y-axis than this guy? It looks like it is. So f of negative 3 is less than g of 5. So I'll bubble that in. Now we gotta say, is f of negative 5 which would be f of negative 5 would be somewhere way up here. As f of negative 5, is that greater than g of negative 8? So g refers to the red line. We go to negative 8. Seems like that's going to be all the way down here. Even further, obviously. Is this purple dot higher than this one? You bet. So that is true. Now, is f of negative 5 greater than g of negative 8? Yep, that repeats itself. So you know that's true again too. Which all the answers are marked correct. Good. Let's squeeze in one more. So these are challenging problems. So it says, the figure shows a graph of a function of f of x, which we're going to have to graph ourselves, in the xy coordinate plane, with the vertex at negative 3, 11, and the zeros are the ones that are crossing the x-axis. So here's our equation that we got to graph. Y is greater than or equal to negative 1, x squared minus 6x plus 2. So let's graph that equation. Negative 3, 11, is that coordinate right there, which I'm going to guess I'm doing this line in purple this time. I could set that equation right into our graphing calculator. So we hit the on button, hit the y equals button. In your y1 section, I want you to type in negative 1 x squared minus 6x plus 2. Hit second graph, that brings up the table, and it will tell you our answers in the table. So when x is negative 3, you know the y1 is 11. When x is negative 2, you know it's at 10. And when x is negative 1, you know it's at 7. And then vice versa. Negative 3 is at 10. Sorry, negative 4 is at 10. And then negative 5 is at 7. So we make our nice little purple parabola. Then in red, I'll make the g of x line, which is 6x minus 7. So we go to negative 7 because that's our y-intercept. We go up 6 over 1, up 6 over 1. We connect them up. I like making my line all the way through the graph to make my life a little easier. Now we got to compare some points. And I'm going to compare via the blue dots here. So f of negative 4, well, f refers to the purple line because that's our f of x function. So f of negative 4. So our function at negative 4, 1, 2, 3, 4. Our function at negative 4. Is it less than g of negative 4? Well, g of negative 4, the red line at negative 4, is all the way down here. So is f of negative 4 less than? No, it looks like it's greater than. F of negative 4 is taller than the g of negative 4. So that's not going to work out. That's a false statement. F of negative 6, that's around here on that blue dot. Compare it to g at 5. Well, g at 5, 1, 2, 3, 4, 5. That's all the way up here. Is f of negative 6 greater than that dot? No, it's not. It's smaller. So B is also a false statement. Now we got to compare C. F of 3. So in this purple line, at 3, well, it'll be pretty far down. Like way down here. F of negative 3. Is it less than G of negative 7? Well, G at negative 7, well, they're both way off the graph. So when that happens, when they're both off the graph, we're going to have to calculate it algebraically. Which is okay too. You could even do this for all the times if you really wanted to. So our function of 3, so when we put a 3 into here, what are we going to get? Well, f of 3, I could look at my table. My function at 3 is at negative 25. My g of negative 7, well, 6 times negative 7, you know, is negative 42. And negative 42 minus 7 is negative 49. So in other words, is negative 25 less than negative 49? No. So C is not the correct answer. The function at 5, 1, 2, 3, 4, 5, that'll be up here. Is that point less than G of 5? So let's put G of 5 in the calculator, which I bet is going to be all the way down here in negative, but just in case. So F of 5, you know, 6 times 5, oh sorry, put that in the calculator. We know at 5 is negative 53. So F at 5 is at negative 53. Pardon me. So the function, that purple function at positive 5 is way down there at negative 53. Then G at 5, 6 times 5 is 30. 30 minus 7 is 23. So is negative 53 less than 23? You bet. So option D needs to be filled in because that's a correct statement. Now remember, when they say select all apply, there could be multiple correct answers. So you got to make sure you click all the correct answers in order for you to get completely correct. Alright, so if you have any questions, please email me or come to Extra Help or watch the video again. Help guide you along here. Your classwork is 3.5 CW1, graph and quadratic functions, and your homework is 3.5 HW1, graph and quadratic functions. Thank you for your time, and have yourself a good night.